you just change the import. You change the import to /react. And what we have now is API dot, and then we have something like use get posts query.
Wow.
So,
and that is all.
So you just
TypeScript powered inference there.
Wow, that's amazing.
So
I can't
if you
believe
were
what I
your
just
component, we'll talk about it in a second. You would just say this.
We covered so much ground in this showcase. It was originally planned to just be a focus on RTK-Query, but instead we ended up doing a full study on like how did we get from Redux in 2015 all the way to RTK-Query today. So Lenz opened up a blank file and he put in there like what did Redux look like with the big switch statement and the action creators and all the boilerplate. And we showed how all that stuff got removed over the years with things like redux-toolkit and support for hooks and all these other things. In fact, this is 3 showcases in one because we also talk a decent amount about Reselect. There's a fun story that Mark tells about Reselect. You know, the TypeScript team has thousands of integration tests that they run on packages on definitely typed and things like MUI and stuff like that. And one day they made a change to the TypeScript compiler and ran their integration tests and nothing broke except for just one package, Reselect. So what they ended up doing is Anders Hallsberg, you know, the creator of TypeScript, ended up coming and looking at it and working with Mark, and they ended up getting it untangled and getting it fixed. But stories aside, there's so much concrete stuff that they showed in this talk about how they detect and test for and ship for multiple versions of TypeScript at the same time. So they have some very fancy declaration, like ambient declaration merging that they use to accomplish that. In their documentation, they have code snippets like everyone else, but what they do is they run those code snippets against the active versions of their code base so they can know in advance if they did anything that broke some documentation somewhere so they can update it. So I feel like we could have talked for 4 or 5 more hours. If this kind of stuff is interesting to you, please do let us know, and we really hope you enjoy it. All right, bye. Welcome, everyone. We have an exciting roster ahead of us today. We have RTK-Query up to bat. And with us, we have Lenz and Mark. Let's start. Mark, why don't we go to you first and then Lenz, and we'll get going.
Sure. Hi, I'm Mark Erikson. I currently work at a company called Replay, where we're building a time-traveling debugger for JavaScript. It's an amazing company. It is an incredibly useful tool. And I'm getting to solve some ridiculously complicated problems, which is a lot of fun. And in my copious amounts of spare time, I work on Redux.
Awesome.
Yeah, so hi, I'm Lenz Weber-Tronic. I work at Apollo, and I'm a maintainer of Apollo Client, like the TypeScript web client that you might know. And in my free time, I am also maintainer of redux-toolkit and creator of RTK-Query.
Beautiful. So I think like we don't have to go all the way back to like ancient times with Flux and all those things, but could you guys give me like a brief, how did we get to RTK-Query? Because I know there's like Redux and there's like this query thing. What is that? So do you have any like short way of summing up the timeline here?
Yeah. So Dan Abramov and Andrew Clark created Redux in the summer of 2015. I got involved early in 2016. And then summer of 2016, Dan handed over the maintainer keys to myself primarily and a guy named Tim Dorr. And so I worked on it for the next couple of years. And even as early as spring 2017, I had filed an issue saying that we see the word boilerplate being used all the time in relation to Redux. And you know, people are complaining about having to write action creators and action type constants and
the switch statement.
You know, switch statement.
Yeah.
I still don't know why people hate switch statements so much.
I'm not sure either.
People hate switch statements and object spreads, and that is like the single most common complaint about Redux. And so I filed a discussion thread saying like, what can we do to make Redux easier to use, easier to start with, simplify it somehow. And there was a lot of discussion over the rest of the year. The thread didn't really go anywhere, but probably like early 2018, started playing around with an idea for some kind of package that would build in some common Redux utilities and use immer inside for simpler immutable updates. And played around with that a bit over the course of 2018. had some early alphas of what I was then calling Redux Starter Kit. First half of 2019 was focused on React Redux and making use of hooks internally, and then shipping the useSelector hooks API. So we got that done by June 2019. And at that point, I'm like, okay, I think this Redux Starter Kit idea really needs to be the next focus. I think it was like alpha 0.6 or 0.7 at that point. So spent the next few months nailing down what I thought the 1.0 API should look like. Got focused on that. And we shipped Redux Starter Kit 1.0 in, I think, mid-October 2019. And then people probably complained that they didn't know, like, is this like a project starter that you're supposed, is it a repo that you're supposed to clone? Is this only good for beginners? So I hastily put up a poll, debated a couple options, and renamed it to redux-toolkit like a month later. So it's been redux-toolkit ever since like November of 2019.
And that was really weird. Like the amount of people saying I'm too good to use this was staggering. Just because of the name. It was totally weird.
Yeah.
The Redux branding thing. So I guess I have to say out loud, I have always been a Redux fanboy since I think around 2016. I mean, I was using Flux before Redux, before I knew about Redux, so I think that must be pretty early.
Yes.
And I've been through all of the, you didn't mention the immutable JS era being like, I feel like that was the second. It was like Redux happened, and then immutable JS, and then everybody started using immutable JS
and sagas.
Yes, I also do quite like Redux Saga, and we have actually Eric Bauer has been on the Michigan TypeScript channel,
Nice.
and he was a maintainer on Redux Saga, and he has a video on delimited continuations, which is like the most mind-melting video I think we have on the channel, maybe aside from the JSON parser and TypeScript types. So basically, I think what I'm saying is it's been so strange to be so hyped about Redux all these years. Even now, I use Redux a lot. And the complaints that we hear from about the boilerplate are weird to me, because I remember reading like Dan Abramov talking about the switch statement is a really beautiful way to do it because it's all the guts of Redux are exposed to you and there's no magic going on. And I thought that was really cool. But it ended up being the thing people hate the most, which is strange because it was done that way on purpose.
It was really cool, and it is really cool to learn Redux until you have to do it for the third time. And then it gets annoying, honestly. Yeah. Then there was like that old Redux tutorial at some point that showed you that you could, and I say could, it was really just an option to do that, like create a folder for actions, a folder for reducer, a folder for types. And people took all of that as gospel. Like every tutorial just copied that. Nobody learned that you could do something different. For a few years, the idea of the DUX pattern was lurking around, but a lot of tutorials were not picking it up because it was not in the official documentation. So Redux became also like equivalent of, to change one thing, you have to go into 3 different files and 3 different folders and then hook it up in a 4th file and maybe reference it in a 5th file. And that's just not necessary. Like for me, it was, I learn Redux, I understand the pattern, and then in the project at work where I use Redux, I write a short wrapper around that does what I want. The pattern is like very obvious, but we abstract that away because, of course, I don't want to have all that repetition and boilerplate all the time. But a lot of devs did not make that extra step, and they created that boilerplate in their projects. And
there was this library, TypeSafe Actions, I remember using. And I think there was one called Redux Actions, maybe something like that.
There's about 18,000 packages right now that have Redux in the name, I think.
Oh, really? Oh, you have a count on that. That's hilarious.
Yeah, if you just search Redux and NPM, it explodes.
Show us, so you're sharing your screen. Show us like what's different about, so we're talking about all the boilerplate. Where does RTK-Query change that?
The thing is, we're not getting into RTK-Query first because there's an intermediate step.
Oh, okay. Okay, all right.
let me call this Michigan.ts or something like that. I hope I've written it right.
Yeah,
so,
let me actually fill in a couple more bits of like history and progression here.
Okay.
So RTK 1.0 included the create action utility, which takes the action type string and returns the action creator function. It included create reducer. Lenz, did 1.0 even include create slice?
Yes,
I'm not
did.
even sure. Okay.
It did.
Okay. So configure store, create slice, that might have been about it. So the focus was just on writing, basically the core pieces of Redux. Set up the store, write your reducers, get the action creators for free. And one of my goals for RTK was that we're going to find the patterns that the vast majority of the Redux ecosystem are already using and already having to write themselves by hand in their own apps. And we're going to provide reasonable abstractions that do 80% of the work for 80% of the people. So, what patterns are being taught in the docs that they still have to write out by hand? And what abstractions have people invented in the ecosystem? And there's like 50 competing packages for the same abstraction concept that we can build in and just have one version that everybody can use. So we had the reducers. The next major pattern that we looked at, and I think this came out in 1.3, was the standard pattern for handling async requests, which was a thunk. So you dispatch an action before, so you can set some loading status. You make the async request. You dispatch a success or failure action afterwards so that you can save the data or handle the error. This was taught in the docs all the way from the beginning. So we ended up including create async thunk to try to abstract that out. So that's where we were with RTK, with kind of like the RTK package itself up to about mid 2020.
Yeah, and I think we can showcase this real quick for like the default stuff. Everybody who has been watching me type has watched me struggle with things I don't know how to do anymore. This is like very abstracted, your old way of doing something. And then you'd say store dispatch type increment or something. So this is like old Redux. We call it legacy at this point, and as you see, create store is already deprecated with a warning to please use configure store from redux-toolkit instead. So I'd say the first thing is like what you have to know is that usually here would be a ton of middleware and everything set up, and like the whole screen would be full of that, allowed to get the dev tools working. What we're going to do now is you take configure store from redux-toolkit instead. And we're going to use that, and this changes around a little bit because now it's more like this. Then Mark already mentioned a few tools that are in there. We have a create action. So we would say, like in the past, you would have like an action creator like this. And that's like the first thing you can abstract, is you can just say create action increment. And then honestly, at this point, you don't need this anymore, and you could say okay.
Yeah.
So this already gets abstracted here. You lose the constant. You could say my number reducer is, and then we take create reducer here.
Okay, so the first argument's the default state or initial state.
I think so. I haven't used this one for a very long time either. But let's see how it
Me
works.
neither. TS is gonna hate you for trying to pass.
Yeah. That's funny. So you have to pass
TypeScript hates me here. You do increment.type. This is like kind of okay, but it's still a TypeScript problem, and there's a way around this.
Yeah.
But let's ignore that part. This all can also be just replaced if we say.
One quick question.
Yeah.
One quick question about what you have so far. This now at this point, this function with create reducer, we've actually introduced immer under the hood. Is that right?
Yeah.
Yes.
So if we would have something like
see any benefit here because we're.
You could do something like this. And we have modifying code here, but it doesn't matter because what immer does is it just wraps it in a proxy and takes all the modifications and creates an immutable copy in the end.
Got it.
So this saves a lot of code for you, but it's still like, why do we even need this? And it's still a bit weird.
Yeah, like action creators and type string constants were in essence abstractions themselves even before RTK existed. You've never needed them. You could inline the action objects everywhere. You could inline the strings everywhere. It was about trying to reduce duplication. And if you think about it, though, what actually matters is the reducer functions themselves. What are they doing? How are they updating state? But we like having action creators because it provides a consistent interface and API to, like what are the arguments? And that matters more when you're using TypeScript.
Mm-hmm.
Where we are here
in the end, you can take away all that stuff. Yeah, I got you.
Yeah, okay. And what we have here is essentially the same thing, but we create a slice and we created our reducer in here. This is the only part where we have seen real logic happen until now, the state value plus plus. And what it does for us, it creates the reducer function for us, which is a reducer over the state of value number. It creates actions for us, which means we have this increment action, which is a function that doesn't take an argument, and it has the type number slice / increment. If here we get into the first little bit of TypeScript shenanigans. If you would say that action is a payload action of number, and here we would say plus equals action.payload, then we get a type error down here because suddenly this function expects an argument of type number. So we get everything inferred from that, just this definition here. The payload creator, the action creator is completely typed in everything. Don't know what's
that's amazing.
And the stuff we do to make that work.
Oh yeah.
There's no duplication. It's all really straightforward. And then just to show people, like on the increment on line 7, if you put a random letter in there or change something, we would see an error on line 14, right? It's all type safe there, that direction as well, right?
Yeah.
Or changing the name.
Yeah, exactly.
Of it.
Yeah, as you see here. Also, if you would say something like decrement here, and that would end up in here. So we have increment and decrement here. You get your autocomplete here. You can jump between the definitions here. It
wouldn't be off-brand. I wouldn't hate it if you wanted to show the like most nasty part of the TypeScript side of this.
CreateAction.ts and createSlice.ts.
All right, let's take a look. I mean, why not?
And here we are in history. We are in about May 2019. Mark at that point didn't know TypeScript well enough, and someone had committed some types.
Someone, okay. So I had started this library. Like I can point to the chat where I wrote the first prototype of Create Reducer.
Yeah, absolutely.
And it was all plain JS. And for like, I have a whole article where I'm like detailing my journey of learning TypeScript. And I did not play with TypeScript for the first time until my day job in January 2019. And I was getting pretty fed up with people filing TypeScript issues against the Redux repos because I didn't know TypeScript and I didn't know how to deal with those.
And I was one of those people.
Oh, really? Okay.
Yeah.
Is that how you guys met?
Yes.
Basically, yes. And so like end of 18, start of 19, someone actually contributed a TypeScript conversion of the redux-toolkit repo, not Lenz. But Lenz later saw that it had been converted to TypeScript and wanted to start contributing. And there was like a 4 to 6 month period where I could not even contribute to my own library because I didn't know TypeScript.
So what we had going on were just pull requests, so I did the pull request, and then in the comments under it, I taught Mark everything he needed to know to review the pull request. And we're not talking like thread-of-the-mill TypeScript here. This is like mapped types. There's like stuff going on. This has a different notation also, where you can say I have a prepare function here and a reducer function. And the prepare function can change the type. So I could say I take a string in here.
A string and then,
And then I return string dot length or something. So we have internally, we have this payload action of type number, which needs to be correct. But externally, of course, a decrement now has to take a string argument.
Mm-hmm.
Because this allows you to change like that stuff. And this is super complex because if I have any error in here, like this, then this whole object needs to throw an error. And that was almost impossible with TypeScript at the time. It is still almost impossible because we are talking about an extremely like this generic here, which has like all the different values in this object and should just check that an object in itself is consistent. And like that kind of stuff is stuff we had to do back then in the beginning days of redux-toolkit. We're like 2 years away from RTK-Query at this point. This is just redux-toolkit.
Okay. Wow. I mean, this is a common thing. I mean, I'm a big fan of Ramda, the kind of like functional Lodash library. And for years, I've been kind of I've helped out in a couple things here and there. And there's also this Ramda adjunct library that I've contributed a few things to. And I think it's a really reasonable complaint that the Ramda authors have raised, which they said, I don't have a problem with TypeScript. I have a problem with, and then they would show like from line 245 to 257 on the screen right now. They're like, this shit, whatever this is, like, this doesn't resemble the TypeScript you see in regular code bases. I don't know how to write this stuff.
Yeah.
And I have to tell you, I just have to say that's a big motivation for us to have Michigan TypeScript in the first place, because we feel like for library authors, it's almost like there's like another Mike Potat on the channel here once said in one of the videos, calling this TypeScript is almost a stretch. And I love that sentiment because that's what many library authors like you guys and others have to deal with is this code. You have to get into a different mindset.
Yeah.
We've commented a number of times that there's like application TypeScript and library TypeScript.
Yeah.
Like application TypeScript, you're basically just saying, here's some function arguments, here's some React props, maybe here's the JSON data structure I'm getting back from my server, and maybe a few other utils, and that's about it. And it's relatively straightforward most of the time. But when you're writing library functions that are going to be widely used, have to handle a variety of inputs, often need to be configured and flexible in what they accept, like trying to represent that very dynamic behavior in static types becomes insane.
Yep.
Yeah. And just like that one check for the prepare notation is like this super weird type that we have down here. And at some point it was also in the method definition itself. Like create slice options and validate slice options. So you had two different types to get like the autocomplete on one hand, because like we are writing types to get the right autocomplete, and the validation of things that might be two legs on the other hand, that if it's in one type could hinder the autocorrect. So this is like super weird types. And what you said right now is like, this is line 273. And okay, yeah, no, 259 is the first line in this file that contains JavaScript. And it goes for maybe 100 lines, and that could be written a lot shorter, honestly. Like most of these files are TypeScript. Also, if you look at createAction, which was like the first time that I had Mark sit through a ternary in TypeScript types, it was this one. And I added these comments to make it easier to read for him.
That's really funny. Well, whatever it takes. I mean,
and also like
it's
like
fine.
This could have been a normal ternary, but to make it easier to read for review, I created these helper types like with an if in the name and then the else here, because this was just impossible to grok up otherwise. Like, yeah. And that's how I ended up being in the
it's funny.
team.
Like, no, really? Okay, yeah. Wow. Okay. So anybody listening out there, if you want to be on the Ramda team, just follow in Lenz's footsteps, and
they would appreciate it.
That's awesome. Okay, so they would. That's true. Yeah, they often library authors are dreading the day that they have to learn this TypeScript, the library TypeScript, as you called it. All right, so let's go to somehow we should end up at RTK-Query. So what happens next?
Yeah. So we're only 40 minutes in here in the recording. Yeah. So what I did was there was a lot of this. You have a pending type, and you have a fulfilled type and a rejected type, and you write a thunk around it. That like you dispatch the thunk, then something starts. Before that, it dispatches a pending action. After that, it dispatches a fulfilled action, hopefully. So what I ended up adding as like the first real code that I added myself was this tool called createAsync thunk. That essentially like.
While you're typing that, I have to say, a party trick that I used for many years was when people would say they're confused about thunk, I would say, have you read the source code? And they'd say, no. And I'd say, you should go look. The thunk source code for years was like 8 lines long, 7 lines long. It isn't anymore. I did it recently, and someone's like,
comments.
And so, yeah. And but my favorite part is I did that to a colleague that was a very experienced engineer, but just hadn't used thunk before. And they just started ranting because Dan Abramov, for whatever reason, used Babel, even though it was like 5 lines of plain JavaScript. So he was like, I remember him screaming in the office, like, these idiots, like they just use Babel for everything. They don't even understand. And it's just funny.
Yeah.
But anyway, go on.
So essentially what this does, it creates 3 actions for you. It creates a thunk for you. Let me move this actually above the slice. And it's an async thunk with a return type of number and no input. We could also add an input here, then we would see as an async thunk that asynchronously gets a number somewhere and it gets a string as the only argument. You would put that in here as expr reducers, and this is where we have like a builder callback notation.
By the way, I am responsible for the name extra reducers. I didn't like it at the time that I came up with it, but I didn't have any better ideas.
It's been 4 years and we still don't have a better idea.
Okay.
The thing here is we have this thunk fulfilled action. We add a written case for that, and we see it's an action with a request ID, with a request status, and a payload, and the payload is a number. So this is all types that happen in the background. If you look up here, we have written this one type because that's the only type that cannot be inferred. Everything else is inferred here behind the lines. And of course, this is a lot more runtime code too, because it does things that a handwritten thunk might not do, like using a try-catch correctly, because handwritten thunks have the problem that if you're in the success handler and that synchronously starts something else like a React re-render, that React re-render throws an error, you will end in the catch block in your thunk, and then you have dispatched a fulfilled action, and then you dispatch a rejected action for exactly the same thunk that was fulfilled in the past, which is something you usually don't want to do. So there's a lot more that goes into writing a good thunk. This does all of it. And this was like the first async tool and what we recommended in the beginning for interacting with APIs. So this is like the base building block that later was used to build RTK-Query. And I think if you're going for RTK-Query, there was other thing that was added to redux-toolkit, like entity adapters, like different ways of building middlewares, but none of them really led up to RTK-Query. RTK-Query is its own thing. And that's something like Mark essentially kept bugging me for doing something. I have to add, in the past, I've been a contributor on React Async, which was an asynchronous fetching library at the time. From that, there was a working group where they authors of multiple fetching libraries wanted to create a better fetching library. They called it Async Library, but that never happened. But there were a lot of great discussions in there. But we didn't really do anything for, I think, 2 more years. Is it right, Mark?
I think so. RTK 1.0 was end of 2019. I think you started working on the first beginnings of RTK-Query around December 20, maybe. It was the end. It was the end of a year, and I think it was either the end of 20 or end of 21. And end of 20.
It was the end of 20. Yeah, I think so. And essentially there's we generally wanted something like that. It just felt so big. But at the time there were a lot of people on Twitter tweeting. I went over to 10-stack query, which was a React query at the time, and I deleted 300 million lines from my code base. And
which was fair.
It was totally fair, and it was a bit annoying, but the main part was that it showed how many people actually, again, didn't write their own abstraction, but even with this, it's not no code to do that. Kept repeating the same code over and over and over and over again in their code base, to the point where they could call it righteously so boilerplate and get frustrated by it. And that was essentially for me the main point of I want to go on and I want to do something about that now.
There's another point here. So I'm a big fan of understanding tools in the context of when were they created, what problems were they trying to solve, and what were they inspired from. Redux was an attempt to make just another Flux library with some functional programming principles and time travel debugging. And at the time, the context of the ecosystem was, we still have Backbone around and Angular. We're worried about state management. We're still dealing with a lot of like event trigger based libraries with events that can ricochet around the app, and we want to centralize it so things are more predictable. And there's this discussion of side effects. Okay, like your Redux is synchronous, we got to deal with side effects. So there were hundreds of Redux side effect libraries that came out over the next couple of years. And eventually we sort of coalesced around thunks, sagas, and observables. But it turns out that in practice, 90% of the side effects you write are actually just AJAX requests to fetch data from the server. And it turns out that most of the state management you're doing is actually just caching data from the server. And so that's why we started to see these data fetching focused libraries around 2017. So you've got Apollo, ReactQuery, SWR, and Urkel. And these were purpose built for that use case. And so of course it's going to be simpler to use a library that's just, use fetch my data query that is an abstraction that does all the work under the hood versus writing hundreds of lines of general purpose side effecty code that is actually just trying to replicate the same thing, especially if you're not using any other abstractions for that process. So we saw, okay, it's not just general side effects, it's data fetching and caching that people want to do.
Yeah. And also there's this was the rise of these libraries in 2019, 2020, because we had just gotten hooks in April 2019. And before that, I don't say it's impossible. It's totally possible to write a data fetching library with higher order components or render props or something.
Yep.
But it only gets to the point where you can easily explain to a person how to use your stuff if you use hooks. Because all the libraries before that had tried to solve the problem were complicated. And with something like SWR or ReactQuery or also the Apollo client hooks, it suddenly seemed so easy in comparison. And that's why everybody jumped on that. And honestly, we wanted to enable our users to do the same thing, because if you add a new library to the stack, for one, it's a separate library. There's no overlap. And you might have things tucked into each other that are hard to replicate. The other thing is many teams need something like that approved. And that's really hard.
Oh, okay. Yeah.
So we tried that's also the reason why RTK-Query is not a separate package but part of the redux-toolkit package, because people could just bump a minor and they had another tool at their disposal without getting it approved to install another package.
Ah, sneaky. Okay.
In retrospect, that's actually that's probably the best argument for putting all the RTK stuff in the core Redux package. Oh well.
Yeah.
I don't know. I mean, it has a different vibe. I've tried many times to show people your problem. I've said this so many times to people. Your problem was the situational politics of React Redux. Your problem was never Redux the pattern. The pattern is really, really capable. You could make something, and look, here's redux-toolkit. It's great. But anyway, so create async thunk. So okay. Big picture, create async thunk is the thing that powers RTK-Query.
Yeah, on a runtime
Was
level.
RTK-Query named to sort of, because React, like you said, React-Query was big at the time. Was RTK-Query named after React-Query?
Yes.
Kind of? Okay.
No.
Okay.
No. Honestly,
You don't think so?
just I had a horrible name before. It was RTK simple data fetching or something like that.
Oh,
and then I added features and suddenly it wasn't simple anymore, and RTK data fetching just didn't roll off the tongue. So it became RTK-Query because it's just good to say. Also, there's that notion of query libraries, because all of these libraries have the notion of doing queries and doing mutations, which comes from GraphQL. Like a query is something where you receive data from the server. A mutation is something where you change data on the server, which means that maybe something needs to be invalidated, something might need to be refetched, stuff like that.
Yep.
So the query in the name of 10-stack query is already like inspired by GraphQL. We are inspired by GraphQL a lot too, because honestly, I've never used 10-stack query except for trying it out and putting it side to side. I've been using GraphQL for a long time. And actually, I've written this, and I didn't use it for the first year because I was using GraphQL and I had Apollo in my toolchain. Yeah. So I've just written this, and then I went on user feedback, essentially. But let's get started with this. This is a different import. The point here is we wanted to make it available for everyone. We didn't want it to be shipped in the same bundle because we wanted to enable like bundle splitting easily for people. Like people who don't need this API should definitely not have to bundle it in any way. So I'm gonna actually let's get off from here. So we have two main concepts here. We have the base query, which is like the central fetching function. In our case, we just ship with a fetch base query, and we throw an URL in there. We can configure a ton more, but this is basically the gist of it. And then we have the endpoints. And in here, we create just one big object like we've already seen with createSlice. And I can say my getPosts object on here, or my getPosts endpoint is a query against /posts. And if I add another one here, I would say getPost would also be a query with a post ID of type string. And I could go to post ID or something like that. Mm-hmm. Instead of this string notation, I could also put objects in here. So I could say like method is, well, in this case it is get, and it should be get. And also we need to return an object and not an empty method body. And then you have this API, and you put it into your reducers. So you would say API.reducer path is API.reducer. You would also need to add a middleware. So this is what we do. We take the default middleware and concatenate it with the middleware for this API. And this middleware enables you to do stuff like automatic cache collection, removing things from the cache like 1 minute after the last component, using them, unmounting, automatic refetching on mutations and stuff like that. The core is thunks, but we add a lot more stuff that is hard to express in thunks. So it does a lot more.
Yeah, those things you just said now, those are, I couldn't imagine writing a thunk to clear the cache of something a minute after it's very complicated. So that's amazing.
The internals of the internals of the middleware are pretty complicated. I've gone in and rewritten that a couple times, and I'm sorry. I kind of sorry I've messed with it.
Yeah, and here you see like every endpoint is reflected on the API endpoints. We have like an initiate method, that's our thunk. We have like matcher functions, which are essentially TypeScript typeguard functions to match the different actions that the thunk dispatches. And we have a selector that's auto-created. But if you're using React, you actually don't want to care about any of that. You just change the import. Oh God, what did I get here? You change the import to /React. And what we have now is API dot, and then we have something like use getPosts query.
Wow.
So,
and that is all
so you
TypeScript powered inference there.
Wow, that's amazing.
So if you were in your
I
component,
can't believe what I just saw.
we'll talk about it in a second. You would just say this.
Of course, we also have the problem that the return type of those endpoints is not defined.
The return type's not defined.
We haven't said that they return a post.
Ah, yeah.
Mm-hmm.
Yeah,
Which you would have,
right.
I think if you had a normal kind of like API library, it would have that baked in.
You essentially would do something like this. You can also just auto-generate all of this boilerplate code from an open API schema, so you don't need to touch that really. So what we get in here is we look at data, and we see that data is an array of posts. What else you get is like a loading state and stuff like that. And you also have a fulfilled and is success. So if you did is success in here, then you know that this is not undefined anymore. Like up here, it's potentially undefined, but this is a very complex type, and down here, you know, if success is true, then data is definitely there.
I'll tell people watching, if you're not like, your eyeballs aren't just like bursting out of your skull like mine are, it's very difficult to do what's on the screen on line 69 and 70 there. It's very difficult to get that kind of like handoff to happen so that TypeScript understands, because we've disassociated. If you did it with just data and you were checking on data, that's different. That's fine. You have to do unions and discriminate those unions based on this is success thing.
Exactly.
Which means duplicating the type of data, which gets complicated if it has a lot going on.
So this is the file with the tests for our union type.
Which is another fun point. Like we were talking about the problem. I actually did an entire talk for TypeScript Congress a year and a half ago where I talked about like lessons learned maintaining TypeScript libraries. One of them is you literally have to write tests for your types. This file doesn't even run. This is just type checked, and we're testing that the types compile correctly.
And we're also expecting types in certain situations, like errors in certain situations where you do something wrong. All of this is like before type testing libraries that did this were around. Like I think VTest now ships with something, but this is like a lot older. So all these helpers here are handwritten. There's like a lot too.
We noticed this when we were doing the challenges in Michigan TypeScript, and we took all of those equal and expect types and put them into a kind of micro library. Oh, you can look at a browser and
of course you can.
Why,
why would you not be able to?
If it would load.
I didn't know. Well, what we did is it's like literally just the expectant, and I think we actually list RTK-Query. No, it's TanStack-Query. But there's so many projects, Zod, TanStack-Query, Zustan, TRPC, MUI, Typefest, TS Reset. They copy exactly the same expect equal type. And we've noticed that like people don't necessarily understand what the point of that is. And the point is this, what you're showing on your library. When you ship something that like the types is a big portion of the value add of the product, you need to write tests for those types so you make sure that they don't break, because it's breaking, you would consider it breaking behavior, right? If these tests, if the TypeScript types broke.
Yeah.
So you have to do something to make sure they work in your library, and people have come up with lots of ways. So
we also test these types with the last 5 minor versions of TypeScript that were released, because if it works in one version of TypeScript, it doesn't mean that it works in another.
Yes. How do you do that?
Well, so we've actually had cases where a change to the TypeScript compiler, like TypeScript itself, they run PRs against like hundreds of libraries in the ecosystem to see what happens. There's been times when a TypeScript PR broke like one library, and it was like the Reselect library,
Mm-hmm.
Yeah, it's always us.
Yep. And then it's a disaster. Well, that's these, what's the XKCD with the, it's like a bunch of boulders and then it's like one guy in Nebraska.
Exactly, yes.
Yeah.
It's like that.
Yeah.
Well, you guys are the guy in Nebraska in this case, but.
At least we're multiple.
Yeah.
So there's one thing that I'm really proud of that I've never seen in any other library being done at all. And that's something I hope will blow your mind. You've already seen, like, when I removed the React here, the hooks aren't generated.
Mm-hmm.
The thing is, if I jump in here and let me search for that. This is like, I think, this index file here. This is the normal index file. So
the module stuff.
Yeah.
Oh dear.
Oh my god. Let's make this bigger. There's a lot going on in here. So if you look at the React index file, we have this createApi as build createApi with core module and React hooks module. And if you comment this line out, the hooks are gone. And if you put it back, the hooks are back there. And the thing is, we've written it in a way that an external library could create modules that add on top of this. And usually you would think, yeah, enhance a type or something, it will work in some way. But these modules need generics, and they need a lot of generics. They need a generic, like, what's the type of the base query, what's the reducer path, like all of this information is necessary in each of those modules. And you can't have generic, generics in generics in generics. So you can't really do what we're doing here with these modules. Like, you can't have a module that then takes in generics because there's no TypeScript notation for that, frankly.
Yeah, it means you're going to force the users to choose between having good types or having their plugin, but not both.
Exactly. And what we have here is that we have a specific module format where you extend a central module interface.
Oh.
And here you get in all the generics, and then you add the name of your plugin on here.
It's like a symbol, like a unique symbol, basically.
So in the person's library project, they would make an ambient declaration. Wait, so is where you're going next the module or the plugin would provide that ambient declaration for the actual end user in their library to include, and then it all works?
The ambient declaration would automatically be loaded because that library's types are included. The thing is, the module is just a module of this string. And because you have a module of this string, the whole module types get loaded into that now got these generics that we would otherwise not have any way of passing in.
Oh.
And this hack breaks every tooling if you want to do something like a DTS rollup or something. It's horrible. But yeah.
Because at the top you can see there. Okay. So let me try to understand. So because you can extend an interface in the user's code base, they would make a .d.ts file that declare module at redux-toolkit/toolkit or let redux.js/toolkit/query. They would put API modules. They would get access to all those generics because they're there in the first place. They would add a new object or a new property to the object underneath that is their middleware or plugin or whatever you want to call it. And then in there, they pass in those 4 pieces of information that you must have. And now when the actual code gets used, all of that stuff is available.
Yeah, and then you have you declare it as a module of like this module name. And the moment you pull in a module of this module name, everything else gets merged into the resulting target object. And the types for that are like it's horrible. Honestly,
can you go into
TypeScript is
module?
not designed to. I'm sorry for that, but yes.
Okay.
It's not even that bad.
It's not that bad.
The module itself is not bad. Because like you have the name and then you have an init function, and that's essentially everything that's a module. The part is where it gets merged in, and that's this build create API thing, where you say like it's a build create API of certain modules, and then you get a create API function back with those modules with that name. And that's like the central type that merges everything together. And that, like, here we have these modules now. These are all the module names. Like, they are passed through all the time. So API of these modules, here we call them enhancers, essentially builds an API of these enhancers. And here everything floats in.
Oh, cool! You have UnionToIntersection. I have claimed many times to people that this type is useful to know how to build, but never had a concrete example. So thank you for that.
Yeah,
people, this is a common complaint. You know, I love that you're showing this stuff in the full guts because, like we were talking about a little while ago, when we did we did all the type challenges on the Michigan TypeScript channel for 6 months. We had a video every day, and they got pretty intense near the end. We had challenges like UnionToIntersection, and a super common complaint from people would be, this is nonsense. Why do you ever need to do this? You know, and some of them were, we had like Fibonacci sequence implemented in the TypeScript type system and things like that. They're for fun. But this kind of thing really does come up in library code. So I'm so glad to have an example. Wow.
Honestly, we have the weirdest stuff. At one point, we had a type that detected if you were using TypeScript 3.2 or before.
Oh, because it would check for like literal strings or something?
No.
The handling of the never type,
never.
The unknown type changed in that version.
Yes.
We also have types that behave differently if you have if you have
strict mode
null checks enabled. Because like if you if you have strict null checks not enabled, then everything is or null, essentially.
Exact level. Optional property types, I think, is the one you're thinking of.
No, yeah, that one too, but it starts at strict null checks because at that point, if we map over something that's a function, we can't detect anymore if the user declared that a property type is number or undefined. So if the resulting function should have an optional argument, or if they declared that it's number and the argument should maybe be undefined or not, like we don't really know because they don't have the strict null checks on.
I forget sometimes that there are people that use TypeScript without strict mode. It's kind of weird. Like, why would you use strict TypeScript without strict mode other than if you're migrating your code base to strict mode? That's the only reason I can think of.
It's not TypeScript otherwise, honestly. It's a feature subset that makes your life a lot harder.
For sure. So did we get there in Michigan TS? Did we get to, is that the current state of the art with RTK-Query?
I think yes. I think this is like most of the weird stuff we've done. I mean, like you're seeing there's a lot going on here, and we could probably go through the types for a day or two. But like there's a few pointers to very weird things.
Don't tempt me with a good time.
I mean, there's also the nonsense over in the Reselect repo for that matter.
Oh yeah, because you are the other maintainer of Reselect as well. I
took over Reselect in late 2021. The original maintainer had been working on it for a few years and got busy with life. And Reselect is not actually Redux specific. It works with any plain JavaScript data, but it's always been it was designed for use with Redux, and it's normally used with Redux. And late 2021, I had like seen a lot of complaints about like, it would be nice if you could add this feature or make this thing more feasible. Okay, let me actually rant about this one for a minute. So with Reselect, you pass in n number of input functions, each of which has to accept exactly the same arguments, and they each extract some value. So maybe the first one extracts state.a whatever. Another one extracts state.b whatever. The third one looks at the second argument and returns it, etc. And then the output function gets all those results as its arguments and does the calculation. So you're mapping over all the inputs with all and with all the arguments, running all the input functions, passing those to the output. Mm-hmm. The original TS types were old, and so they had to hand specify generic overloads for 1 through n possible input functions.
Yes.
And so it was like, up to 12 possible input functions, because that's as many overloads as were written, except that you can pass them in as either individual arguments or an array of arguments. Mm-hmm. So it doubled the overloads because we had to handle the parameters forms or the array form. So it was like, it was like a 3,000 line type definition file, and it was all separate. It was a separate type definition file. The code was JS. So I took it over.
And then on the user side, if TypeScript accidentally picks the wrong overload, which is pretty easy for it to do sometimes, it's so hard for the user to understand what the problem is because they just see the type and they think that it's right. Mm-hmm. Yeah, I know what you're talking about.
So when I took it over, it was still written in plain JS, had a separate type definitions file. I migrated the code to TypeScript, and then someone else had already contributed an open PR that tried to use some of TypeScript's new like rest spread inference type capabilities and to infer things from the type of the functions that you're passing in. So I took that and I tweaked it some. And by this point, I sort of knew just enough to be dangerous. And so I shipped the rewritten types in the TypeScript conversion as version 4.1, theoretically without breaking changes. And then, of course, probably started getting complaints that I had, in fact, broken things because the inference was still kind of finicky, and there were, it was being used in lots of weird ways. So I spent the next 2 or 3 months trying to make tweaks. I was frequently in over my head, kept having to beg Lenz or people in the React-to-Flux TypeScript channel or a couple times the TypeScript Discord. Like, and I know,
at that point, I have no idea what you were doing because that stuff was already so complicated. Like you would need to read into the point where you were at that point.
And I ended up with okay, Lenz, you could probably dig in here. Go into node modules /reselect since you've got VS Code open.
Oh yeah, that one works because I noticed that I don't have reselect on this machine.
Yep. So what I ended up
node hoisting.
Yep. What I ended up with after a couple months of iteration and a whole lot of begging other people for help, like I knew what I was trying to do in my head. I just frequently didn't know the right syntax for it. Was I ended up with a type that looks at the create selector call, extracts the type of all the input functions as an array, does a types level map to extract the type of all the arguments as an array, merge parameters. Let's see, I think it's probably around the middle, I think. Control F, merge parameters. Oh yeah. Oh, then there's the version type nonsense. Yes.
Oh my God, I forgot that.
And you want the TS 4.6 version of this? Okay, so
not the 4.7. Yeah, that's the old one, right? Okay. Oh yeah.
Oh boy.
You'll notice that I heavily commented this because I couldn't remember what the heck this was doing otherwise. So we extract the type of all the parameters for each of the inputs. Then we have to map over them, transpose them. So we have like an array of all the params at index 0, an array of all the params at index 1. And the goal is we're trying to come up with what is the tightest combined type of arguments that our final generated selector function can accept. And to do that, we have to intersect all the types at index 0, all the types at index 1, because like, okay, most of the time, all these functions are going to take a Redux state object as the first parameter, but you could have like numbers, strings, props objects, whatever, as additional parameters.
There are no rules about what that type is.
Right. But all of them are going to get called with the exact same arguments, so they all have to be valid and matching compared to each other. You can't have one function say my third argument's a number and another function say my third argument's a string. That's not valid. So we have to intersect together all the parameters at the same index and then say, okay, now we kind of flatten this down. Here's the final type for parameter 0, the final type for parameter 1, and turn that back into an array because that represents the final argument types of the generated function. This was insane. It's like it's still one of the things I'm proudest of. Like I repeatedly had to beg for help to make this work, but it worked. And then it broke in TS 4.9. This was like literally they broke one thing in the ecosystem and it was this type. So they pinged me because I was the maintainer and I tried to explain what the heck this type was doing. And Anders Hellsberg himself, the creator of TypeScript, came up with a better, simpler implementation in the other file, but it only worked in TS 4.7 and higher. So now we've got a problem because like we've kind of had like a rotating, shifting list of what TS versions we support, and we don't even change it in majors, we change it in minors. We just sort of look at like what's like the last
TypeScript doesn't follow some
4 or 5 TS versions or like TS's string changing support in TS 4.1 was a big shifting point. So, you know, for a long time, like we had TS 4.1 as our minimum. And I think at the time that this broke, I was still trying to support like TS 4.2 and higher. So now we've got a problem because I still would like to support all the way back to TS 4.2, but TS 4.9 breaks things. But this only works in 4.7 and higher. So Lenz had come up with this horribly stupid hack that we used in RTK for a while, where you've got an extra nested package JSON. It's not there for real during local development, but during the build step, we copy this to the output folder, and it uses the types versions field to say if it's a newer TypeScript version, look at file A. If it's an older TypeScript version, look at file B. And we import from this folder. TS sees the package JSON file and forks which version it's reading from. And so I had to copy paste and use this over in Reselect.
I didn't even know about this types version property.
Types versions was never meant for this because it's usually only meant for the entry, and they assume that you copy the whole folder with all your types into 2 versions.
And we actually did use this at the top level of Reselect for a while because I was still shipping the old 3000 line type definitions file to like for people who were using before TS 4.2.
Wow.
Yeah, it's still there.
Wow. But okay, so that means though that for users that are just consuming Reselect, this all works without them knowing that what's going on or having to deal with anything. Just work.
Yeah.
Wow.
And this is
I bet you're excited to get rid of this someday.
Someday is now, actually. So
good.
So what you're looking at here is our master branch, which represents RTK 1.9 and Reselect 4.1. This whole year, we've been working on major version releases for the entire family of Redux packages: Toolkit, Core, Reselect, Thunk, and React Redux. The biggest piece of that work has been trying to get proper ESM Common JS compatibility, which has been a nightmare. I've written an entire blog post on
Nobody seems to know what that means.
I've been beating my head against the wall trying to make that work. It mostly works, I think. I've written, and I ended up doing a blog post and a conference talk and like 3 podcasts on how much of a nightmare it's been. But as part of that, like
thoughts and prayers.
Yeah, we've also updated like the TS versions we're targeting. So we're now using 4.7 as our baseline, which actually meant like several of these hacks are gone in our beta versions.
Mm-hmm.
Yeah.
Thankfully.
Wow.
Like one thing I wanted to point out, the 4.7 version is also using, I've seen it somewhere, tail recursion.
Yes. Tail recursion is important for TypeScript type performance. I mean, do you guys ever wish? Do you ever wish for TypeScript debugging or?
Yes, constantly.
Yes.
My! I would kill to have a step-by-step TypeScript debugging tool.
Yes.
This came up recently with you guys know Orda. Orda used to be on the TypeScript team.
Yeah.
Well, we had a video with him 2 or 3 weeks ago where we looked at somebody implemented Conway's Game of Life in TypeScript types purely. So we were going through that, and Order was on that call, and he mentioned that this comes up a lot, that people want debugging tools like to be able to step through what the types are doing. But the reason there is no such thing is there's no intermediate representation of TypeScript types. It's like for inferring pieces of strings, for example, with mapped condition or with conditional types, it's like literally string.slice in the TypeScript compiler code base. There's not like a thing that it goes to first, and then like there's no like S expression language that TypeScript compiles to, or there's no syntax tree like for the types themselves. It's like done on the fly dynamically in the code base. So I don't know, but there are people working on performance tools. Have you had any forays into trying to measure the performance? Like you mentioned, tail call recursion.
Oh, we have a great example recently. So there was an open issue even just a couple months ago in the RTK repo complaining that IntelliSense got really slow when you were using RTK, like a multiple second delay sometimes. And I'd actually just seen some tweets and some comments, specifically from Alexandra Sikora and Matt Pocock. Yes, it would be on the against the 2.0 integration branch.
Didn't we backport and release that?
Actually, yes, we did. Yes, we did. Probably late October, mid September, thereabouts.
Maybe I needed to pull.
So I'd seen some recent discussion of measuring TS compilation performance from Alexandra Sikora and Matt Pocock. Alexandra did a couple conference talks. She did a stream with Matt Pocock.
Yep.
And so I'm like, okay, let me try poking at this a little bit. And I've done a fair amount of like JavaScript performance profiling. I'm very, very comfortable with like hitting the record button, looking at a flame graph, etc. And someone in that thread had provided an example, which was just like a stupid synthetic thing where it generated like 400 endpoints to force it to be, to do the same thing over and over. Go search for the hook names type and look at the history of that file.
Oh god.
They
do you remember how that was? I don't know where that was, honestly.
Control-Shift-F hook names.
Like really hook names?
Yeah. It's under probably build hooks, maybe. Might be a separate file. Do a text search for hook names, maybe.
I think it's in the module. Named hooks here.
There we go.
Yeah,
okay,
this one.
There we go. So I did a performance. So Alexander had given instructions for running a couple certain commands. There's one command you can run that tells TS to print some detailed stats on how much time was spent reading files off disk, how much time was spent parsing things, how much time was spent generating types. I'm like, yep, it's taking 3 or 4 seconds to parse some of these types. And there's another command you can use to spit out a JSON file that is basically Chrome trace format. You can load it into, like, you can open up any Chrome DevTools, import the parser or the parsed output, And it just shows like, you know, the names of like the internal parsing logic or some of the types that it's looking at. And I was able to look at that and just eyeball it and say, okay, like this section of the flame graph, it's parsing it's loading the files off disk. Here's like a 2-second block where it's parsing one type. What is that? And just looking at the flame graph info, I was able to narrow it down to this hook names type. And here's where it's doing that magic that says, okay, you have endpoints of get posts, get post singular, and update post. Let's convert that into the top level. Use get posts query, use get post query, use update post mutation. And it was doing it by doing a whole bunch of mapping over those types. And I looked at it and I saw that the biggest piece was it was dealing with a giant union type in that one example of like 400 different things unioned together. And so I'm like, maybe the problem is we're generating a giant union. I don't know, maybe. So I hypothesized that if we somehow generated this type more efficiently and it was a smaller set and it was intersected, that maybe it would be faster. And it was late one evening. I couldn't come up with the exact syntax myself, but I tossed it out in our internal discussion channel. And Ben Durant, who's a relatively recent Redux maintainer and is also a TS wizard, much smarter than me, proceeded to whip it out like on his phone or something because he does that. Like seriously, he writes valid TypeScript types on his phone. But he whipped this out, and then I pasted it in and tried it, and sure enough, it shaved like 60% off the time to calculate that.
Wow. That's incredible. And the way that it did that was by creating a single map type with a smaller set of, I see you're excluding
like
from the
keys. Three small types that get intersected together.
Mm-hmm. It's essentially where you had the and here, we just split it into 3 different types and then we AND them together. It's the same thing if you look at it as a human, but the compiler can cache those better somehow, and it really
and we don't
really speeds things up for users.
And we don't end up with a union type of n things together.
Yes. Oh, okay, because it's intersecting now. Wow, that's quite a story. Okay, I love that. It's very exciting to see these things emerge, and I think that like we're getting to a point where somebody is going to figure out, you know, a way to like you said, Matt and Alexandra, that they're doing a lot of this work to kind of like start the conversation and get people like at least being able to see something about what's going on. Because before, I mean, even like a year ago, it was just a black box. I mean, you can't tell what's going on inside.
It's not perfectly black. There's one person on the planet who can look through that.
His name's Mateusz Brzezinski.
That's under Restrake by his nickname. And he uses a replay to
Mark's company
to essentially record the TypeScript compiler working, and then uses the time travel step through profiler there to get to certain points. And he is good enough in reading the TypeScript source code that he can point out what exactly is a certain type at a certain point. And I the idea that someone can do this is still like flabbergasting to me. But he does.
Yeah, that checker.ts file is quite a doozy.
Yeah.
I think Alexandra and Matt are working. I think they said on a site, I think it's like tsperf.dev or something along those lines, that is like they're trying to build tools to make TS compile performance checking more accessible. Like I don't think there's anything available yet, but they announced recently they're working on that.
That's incredible. Well, that's going to be a smash hit because so many people really, really need this. And if you can make it easy, I mean, some of these things are really complicated until you get a tool. Like for people who don't know, there's like, are the types wrong? Have you guys seen this one?
Yes. That was a huge piece of my ESM work this year.
Oh, actually, yeah, Mark, what the hell? What am I talking about? Yeah, of course you've seen it. You were like, I remember you commenting on the thread about wanting a CLI, or you had been working on a CLI of something similar.
I hacked together a first prototype of a CLI wrapper for that so that I could use it in the RTK repo. The actual official CLI that got released later didn't use any of my code, but I at least proved that I could do it, and then that kind of helped nudge someone else to make a better version.
Spiritual successor.
Yeah.
Yeah.
Well, I mean, so this is a showcase on Michigan TypeScript channel. The first showcase we had a couple months ago was with Andrew on Are the Types Wrong? And Andrew Branch from the TypeScript team. And I love that tool so much because it took something that was really contentious and really difficult and really hard to wrap your mind around, even for very advanced TypeScript engineers who had been writing JavaScript for a decade. Many of us really struggle with that stuff. But all of a sudden, you run it through Are the Types Wrong? And suddenly you have like something tangible to feel confidence about what you're shipping. And I'm so excited for tools like this to emerge with this stuff that you guys have been showing in this call, like the TypeScript library code stuff. It's really fantastic work that's being done.
But honestly, with other types wrong, like all I do is like, I'm getting less red access. Like I still have no idea what I'm doing or why I'm doing it. I'm just like, I'm getting gamified into getting a better score in the end. But if it works, it works. Honestly,
it works.
And Andrew's done amazing work trying to document how TypeScript handles modules. The Are the Types Wrong site / markdown files in the repo. He's got explanations of what each of the errors actually means. It still doesn't necessarily mean you're going to be able to fix it properly, but at least it explains what this means in theory. And then he just published a entire new documentation set for the TypeScript site on how TypeScript understands modules conceptually.
Yep. He's been working hard on that for a long time. It's really, that's the tough stuff. Well, we have so much more that we could talk about. I wanted to ask you guys like about documentation and how your approach to deciding.
Okay,
what to take.
now you've nerd baited me. Give me a second.
No.
Like three more minutes.
Okay, all right.
I got another couple hours until my next meeting.
I have to call this quits soon, but this is actually something where I've done something. Our documentation is tested against the types of the source, against the source code.
Really?
So
this is my favorite. While you're finding the file, this is one of my favorite things that Rust does. In Rust, if you put documentation in an example above a function, like sort of think of it like JSDoc, and you run cargo test, it will run those things, like run the code in your example above your function. It's really neat concept.
Nice.
I'm just trying to find a code example that doesn't have no transpile in here. Because we do a lot of things. Mark, do you have an idea where I find something nice?
CreateSlice probably does.
Yeah. This one, for example.
Okay.
So what our docs do here is they take this, they compile it against our source code to see if there are any errors. So if we would change something that would change the documentation example, like make it throw an error, our documentation wouldn't build anymore. We also transpile this to JavaScript, so you get the side-by-side tabs in the documentation.
Oh.
And we have a lot more complicated examples down here.
There's some that have like multiple files in there. So there's like a virtual file system.
Like where you set up a virtual file system in the comments, and that's not displayed to the user, but it's used for the type checking and stuff like that. So that's a remark plugin that I've written to do all of that. And the other part of that remark plugin is extracting parts of doc blocks and injecting them into the documentation, into the written text. So you have like not that auto-generated stuff, but you have like flowing text, but in between you don't have the duplication between source code and.
I'm curious why you took this approach instead of inline, MUI. I think it's been a while since I contributed to MUI, but last time I looked, they just create the files. And they have a system that does the opposite. It will inject the files get transpiled like normally through picking them out one by one, but they're regular TypeScript files. And then the actual markdown generation has a bit that injects the code from those files. Why did you choose to go this way, putting all the code in the markdown rather than putting the markdown in the code? Do you know what I mean?
We did put the markdown in the code. For that part, like for extracting doc blocks, we have the markdown in the code. And we just reference it as a link here. And I for the life of me, I can't find an example for it now.
Like I think it's actually like why did we not write some of these samples in the docs as standalone TS files?
Yes.
Because that's the way we wrote the docs examples to begin with, and we just wanted to keep going with it.
Okay. Well, good reason. Yeah, that's fine.
And this one here, for example, would inline an example from the doc block of map builder's action reducer map builder add case. Inline the example from that. The example would become part of this markdown, and then it would be transpiled.
Oh, so that's how you get both.
And checked for errors.
Wow. And it's caught. I'm sure it has caught errors over the time that you've been using this.
Mm-hmm.
Yeah.
It also makes the docs take like 8 to 10 minutes to build.
Yeah.
Yeah, but I mean, 8 to 10 minutes is nothing compared to the headache of having to fix something later, that you broke. I mean, does it ever happen that it shows you things that, like, the docs are correct, but the code actually did something wrong? You know what I'm saying? Or is it always that the docs are wrong and need to be updated?
It's generally that the docs need to match the source code.
Interesting.
It shows you, like, if you break a pattern that you have documented, then you probably don't want to break that pattern. So it's another level of tests, and the docs essentially become your tests if you want like this.
It encourages you to put lots of detail into the docs. Sometimes authors are afraid to do that because they know how painful it's going to be to maintain the docs.
For that question, why don't we just put that in separate files? This is actually a really good example of that, because I also want to do other things with that. So I'm in createReducer, I'm in the 0th overload, and I just want the summary of the overload here. So what it does for me is it takes this part and copy pastes only this part over in into the docs. And that way I can have like only I can pick parts from my comments into the documentation, and if there's do contain examples, like here I have an example block, this whole example would get type checked on top of it. And
is this a package that I can use? Like, did you?
Yes,
is this
yes.
Generalizable?
TS remark tools, I think. Or remark TS tools.
Yeah, I mean, over the years, there's this thing called CQ that I've used in the past. It's by newline.co/CQ on GitHub. And it's a very similar type of thing where you it's inspired by JQ, It made syntax for actually saying, like, you can say, I want these lines, or I want this overload, or I want, stuff like that for querying code files. It'd be under the
Lenz
folder, right?
Website folder.
And the website folder. We have too many folders in here. Yeah, it's remark TypeScript tools.
Gotcha. Wow, great. Okay, I'm going to have to check that out. This is something that I think everybody needs, right? I mean, somehow, I don't know, like, anybody who's out there looking to start a company, like, please start a company that does, like, really focused on the docs experience for developers, because it's the biggest thing that some projects can do to get adoption and get happy users is to have well-documented stuff. But then as soon as you start documenting things well, you immediately find out you regret it because it's so hard to maintain. And someone's got to fill that void. So I'm glad to see you guys working on this and showing examples of how to do it. That's awesome. Well, I won't nerd snipe you again. There's more. But we could come back another time and talk about more of this stuff. So I guess anybody watching, like, let us know down below if there's something else we didn't cover that you'd like to talk about. There are no rules here, so we can come back next month and talk more. I think, Lenz, we were gonna maybe talk about Apollo stuff. Maybe we'd come back and talk about Apollo client and all those other things. Mark, of course, you're welcome anytime. So if you have things too that you think are interesting to talk about, I'm so happy with how we got into the weeds and looked at all the types and stuff. That's exactly what we want to do with this series.
I love
on this
talking
channel.
about this sort of thing. I don't get nearly enough chance to do it.
That's awesome. Well, you have your window of opportunity here now on Michigan TypeScript. So anyway, with that, abruptly, thank you guys so much for your time. It's been really awesome. And where can people find you, or where should people? I think you're both on Twitter or something like that, right?
I'm at AceMarkey in most places, at Mark Erikson on GitHub, blog.isquaredsoftware.com.
Cool. Lenz?
Yeah, for me it's Fry, so PHRY on Twitter. Frenius everywhere else on GitHub, Discord.
Is that a
Stack
Futurama
Overflow.
reference?
No, that's like 10 years older than Futurama.
Oh, okay. All right. Well, all the same, thank you so much, guys. And yeah, we look forward to stuff in the future. It's been real fun.
Thanks.
Yeah. See you.